Hello everyone, welcome to Think Global Education Services SAT Math class. Guys, the topic for today is geometry. Now, geometry is a very wide domain. There are a lot of things that we need to cover in geometry in our SAT. We have lines, we have triangles, we have circles, we have polygons. Okay, so we have different set of rules. Now, I'll be making few videos on geometry. So I'll start with circle. Okay, so let's understand what are the properties that you need to know regarding the circle in your SAT. So let's start. The first property is length of the arc of a circle. So if I draw a circle, let's say this is a circle. If I take the center point, let's say O, and if I join the radius, so these are the radius. Let's say the radius is R. Now, when I say length of the arc of the circle, they are actually concerned with this length, the length of the arc. So that's an arc. Now, the length of the arc of the circle is given to me by a formula that is 2 pi r theta over 360, where r represents the radius and theta is the central angle. So this is the formula of the length of the arc. It is just nothing, it's just the part of the circumference of the circle. So the formula here is 2 pi r theta by 360. But how this formula is actually developed, if you notice, for example, if I say the central angle is complete 360 degrees. So if the central angle is 360 degrees, the length of the arc will be nothing, but that will be the entire length of the circle, which is the circumference 2 pi r. So if I apply the basic unitary method, if the central angle is 1 degree, it will be 2 pi r over 360. And if I say the central angle is theta, I'll simply multiply this with theta, and that's how this formula is developed. That's 2 pi r theta by 360. So that's the length of the arc. Now moving forward to the second formula that I need to know, which is area of the sector of the circle. So if I take the area of the sector, so if I draw a circle again, this is the center O, I take the radius R. So this is the radius R, and we have, let's say the central angle is theta. Now when I say area of the sector, it's like a piece of a pie. That's the shaded portion we are concerned with, area of the sector. Now area of the sector is given to me by the same thought process, that is pi r square theta over 360 degrees. Now the thought process is same. If I say the central angle would have been 360 degrees, we acknowledge the entire area of the circle will represent the area of the sector. So if the central angle is 360 degrees, area of the sector is nothing but the entire area of the circle, that's pi r square. So applying the basic unitary method, if it's 1 degree, it will be pi r square over 360. And if I say the central angle is theta, I'll just multiply this with theta, and that's how this formula is developed. That's pi r square theta over 360 degrees. So these are the two formulas that I need to know. Moving forward, cyclic quadrilateral. Now what do we understand with cyclic quadrilateral? As I've already drawn the figure in front of you. A quadrilateral where all the four vertices actually touch the circle, then only a quadrilateral is said to be a cyclic quadrilateral. Now be careful, if I take a circle and if I draw a quadrilateral inside a circle, that's not called a cyclic quadrilateral. This is not a cyclic quadrilateral because the vertices are not touching the circle. So I can say if a circle is drawn passing through the four vertices of a quadrilateral, then the quadrilateral is said to be a cyclic quadrilateral. Now you just need to be aware of one property regarding the cyclic quadrilateral, that is the sum of opposite angles in a cyclic quadrilateral is always 180 degrees. So here I can see angle 1 plus angle 3 will be 180, and angle 2 plus angle 4 will also be 180 degrees. It's a very basic property that you need to understand regarding the cyclic quadrilateral. So I hope this is clear. Moving on to the next property. Now this is a very interesting and a very important property in your SAT. Now the property says if an arc of the circle, do you realize this is an arc? That's an arc of a circle. Now if an arc of a circle, let's say if I give label this, let's say BC. This arc BC actually subtends an angle of x at the center. So I say the angle subtended by this arc at the center is x. Now the property is if an arc subtends an angle of x at the center, the angle subtended at any other point on the remaining arc. So since we are talking about the angle subtended by the minor arc, so the remaining arc is nothing but this major arc. So if an arc subtends an angle of x at the center, the angle subtended at any other point on the remaining arc will always be half of it. So no matter whatever angle I take on this remaining arc, all these angles will actually be x by 2. So that's a very important property for a circle. If an arc subtends an angle of x at the center, the angle subtended at any other point on the remaining arc will always be half of it. So based on this, if I say angle O is 132 degrees, angle A will actually be half of angle O, that is 66 degrees. So that's a very important property. If an arc subtends an angle of x at the center, the angle subtended at any other point on the remaining arc will always be half of it. So we'll see the application of this property as well. So these are the few properties that you need to know regarding the circle. So a quick recap. So we did area of the sector, that is pi r square theta by 360, length of the arc, which is 2 pi r theta by 360. Then we did cyclic quadrilateral, and then we did the last property that I just told you. Now based on that property only, they're asking me angle in the semicircle. So suppose if I take a circle, if I want to draw a semicircle, I'll just take the diameter. Let's say this is the center of the circle. Now by using the same property, I know that this bottom arc subtends an angle of 180 degree at the center. If this bottom arc subtends an angle of 180 degree at the center, the angle subtended at any other point on the remaining arc will always be half of it. So I can say that this angle is nothing but half of 180 degree, that is 90 degree. And I can take whichever angle I want in this semicircle. All the angles will actually be 90 degrees. So from here I can understand that angle in a semicircle is always 90 degree. So these are the 5 basic properties that I need to understand in a circle, and if I know these properties, I'm done in my SAT regarding the circle. So let's try, just take 1 or 2 examples to understand them better. Okay, so let's try this question. It says, if O is the center of the circle shown above, OP is equal to PQ is equal to QR. So they are telling me that OP is equal to PQ is equal to QR. All these 3 sides are equal. What is the value of X? Now, do you realize this OP is nothing but the radius of the circle? And I can see this OR is nothing but the radius of the same circle. So it has to be equal. All the 4 sides becomes equal. Now the general trap that we have here is, most of the students, what they think, if all 4 sides are equal, it becomes a square, and if this becomes a square, this is 90 degree and this will be half of 90 degree, that's 45 degrees. So that's a trap. So be careful guys. When I say all the sides are equal, it does not mean that it's a square. If all 4 sides are equal, the figure is actually called a rhombus. So be careful, don't assume it to be a square, and if you assume it to be a square, you will end up in a trap. So first of all, it's not a square. Then let's understand how do we solve it. Now, I'm just quickly drawing the figure again. So here, this is the center, and if I take this is OP, PQ, QR, and OR. Now O, P, Q, R. Now if I do some construction and if I join OQ, do you realize OQ is also but the radius of the circle? So I know that these three sides are equal, so it actually becomes an equilateral triangle. Similarly, the bottom triangle will also be an equilateral triangle. So in an equilateral triangle, I know this angle is 60 degree and I also know that this angle is 60 degrees. Now I will join this PR. We are concerned with this angle X. Now do you realize if you just look at triangle in triangle OPR, it's an isosceles triangle. OP is equal to OR. So if the sides are equal, the opposite angle will also be equal and this angle will also be X. Now if I just take the sum of the interior angles, so this complete angle is 120 degree. So it's 120 plus X, that will be the sum of the interior angles of a triangle, that's 180. So 120 plus 2x is equal to 180 degree, and that will make 2x as 60 and x will eventually come out to be 30 degrees. So be careful here guys, option number C is a trap and the correct answer is option number B. So I hope this question is clear. Now moving to the next question. In this question they are saying in the figure above, O is the center of the circle. The measure of angle ACO is 30 degrees. So ACO is not drawn, so I'll do some construction. Say ACO is 30 degrees. So this angle is given to be 30 degrees and they are asking me what's the degree measure of angle ABC. That's what they are asking. First of all guys, you should be very careful here. Sometimes students believe that it's a cyclic quadrilateral. It's not a cyclic quadrilateral. Okay, because all the four vertices are not touching the circle, so we'll not apply any property of cyclic quadrilateral here. So let's see, we'll try to apply the property we learned. So I know that OC is equal to OA, both are the radius, so this angle will also be equal, will be 30 degrees. And if I take the sum of interior angles of a triangle, I know it's 180. So 180 minus 60, so that becomes 120 degree. Now I figured out this angle O, that's 120 degree. Now from here, there are actually two ways of doing this question. Now one way is, I told you it's not a cyclic quadrilateral, but we can actually construct a cyclic quadrilateral and join A and C, let's say at point D. Now do you realize A, B, C, D is a cyclic quadrilateral, and the property that we learned was if an arc subtends an angle of X at the center, so I can see that this arc is subtending an angle of 120 degree at the center. So the angle subtended at any other point on the remaining arc will always be half of it. So this angle will be 60 degrees. And since it's a cyclic quadrilateral, I know that angle B plus angle D will always be 180 degree. Angle D is 60 degrees. So angle B will come out to be 120 degrees. So this angle comes out to be 120 degrees. So that's one way of doing this. You see, I did not use any other property which I have not discussed. I've used the cyclic quadrilateral and I've used the property that the arc subtends an angle of 120 degree at the center. So the angle subtended at any other point on this major arc will always be half of it, that's 60 degrees. That's one way. So I hope this way is clear. But there is another way of doing this question. We can actually solve this question without drawing the cyclic quadrilateral. We really don't need to draw the cyclic quadrilateral. We can still figure out. You just have to visualize a bit. If you want to be good in geometry, you have to visualize the figure. Now I figured out that this central angle is 120. Now if this angle is 120, what will be this bigger angle? I know the total is 360, so this is 120, this directly becomes 240 degrees. Now I can apply the property that I just learned here also. I can clearly see that this major arc actually subtends an angle of 240 degrees at the center. So the angle subtended at any other point on the remaining arc will always be half of it. So I can clearly see this angle B will directly be half of 240, that's 120 degrees. So you can very well draw a cyclic quadrilateral, then understand it, or you can directly understand with the property. Because if the major arc subtends an angle of 240 degrees at the center, the angle subtended at any other point on the minor arc will be half of it. So guys, I hope the 5 properties that I've discussed is clear, and these 2 questions I've discussed is clear. So guys, that's all in this video, and I'll post few more videos on geometry, because there are a lot of other things that we need to cover. So I've just covered the basic of circle in this video. Thank you guys.